Okay, so we'll have a few people going around helping you get to aquarium. Let me plug in here really quickly. And let's see, I'm plugged in. And okay, so it looks like you can see my screen here. Before I start there, let me mention a couple of other things coming up. We have an event, a Dive into H2O training event, full day training in New York, which is going to be happening, what's the date here? November 4th. So that is on Eventbrite. You'll be able to find that on our homepage. I would invite any of you that are interested in more in-depth training. This is going to be a really good kind of one-day event, and our training team and a number of our expert data scientists will be there to help support that. So that's the first piece I want to mention to you. The second is, as you're getting to your login on Aquarium, there are a number of tutorials available online. And these tutorials are all hands-on. We have a team that has been working very hard creating a lot of these, everything from getting started with driverless AI, a test drive, financial focus, machine learning interpretability tutorial, time series tutorial, etc. A lot of great material here. And so let me reference that as well. More places that you can come to learn more about all of our software, including driverless AI. So once you've logged into Aquarium, and let me pause here for just a second. How many people are actually logged into Aquarium right now? Okay, so a good number of you. Once you're logged into Aquarium, go over here to Browse Labs, click on Browse Labs, and you'll see a list of labs. And by the way, now that you have a login to Aquarium, feel free to come back and revisit this and use it as you will. There's a lot of things you can explore through here. What I would like you to do is come down to David Whiting's Driverless AI, the 1.8.0 lab, and click View Detail. There's a lot of information here, and so feel free to come back and read through that. I'll just voice over it. Click on the very bottom and click Start Lab. And you should see an instance come up. Now, if you're doing this on your own, it will take a little while for these instances to come up. We've kind of preset a number of these up. Click on that URL. There's an evaluation license. Go ahead and agree to that. And here's the important part. When you get to the login, I would like you to use training as the username and training is the password. And so what you're seeing right now as you first log in, and I know some of you are continuing to log in, so I'll speak a little bit before we start moving on this. This is what driverless AI looks like after you've been working on it for a while, right? We have a number of data sets that we've loaded, a number of projects that we've built, visualizations, experiments, deployments, etc. So we're going to do sort of a high-level overview here, but you're actually going to be building things today. So how many people are at this page right now? Okay, let me talk about the data.
Who's not at that page needs help? Okay, keep your hands up, we'll keep going around.
So let me speak about the data set we're going to use really quickly here as a motivating example. All of the data sets we use in training, by the way, are obviously open source so that we can freely distribute them. Most of them you can find on like the UCI machine learning library or from government sites. A lot of them find their way into Kaggle, and so as tutorials or whatever. This credit card example is one such case. This is a data set that comes from a bank, a lender in Taiwan. We've got about 6 months worth of data in 2005. And the goal of this is to build a model that will determine who's going to default on their next month's credit card payment. So kind of a very typical situation. We've got some information on historical payments, demographic factors, credit history, etc. So a real basic kind of nice data set to work on here. I do want to mention, so this is available at the UCI Machine Learning Library. It's available on Kaggle. The way that I got very confused when I first used this, so I went back and relabeled things, so the labels will look different from mine, from what you see if you get the original data. Again, you're always welcome to come back and visit Aquarium once more to do this. So let me talk through the data really quickly, and then we'll look at this data within Driverless AI. So my columns are, I've got an ID. For each customer, I've got an indicator of whether they defaulted on their next month's credit card payment. I have their credit limit. This is in new Taiwanese dollars, so the numbers will look really big. It's a couple of orders of magnitude. Take a couple orders of magnitude off and it'll be kind of comparable. We have some demographic information, sex, education, marriage, age. And then we've got these things labeled 1 through 6, status, bill amount, and payment amount. So let me explain what these are. The 1 through 6 refers to how many months ago this information was, right? So bill amount and payment amount are pretty straightforward. Bill amount is what was their bill last month, 2 months ago, 3 months ago, all the way back to 6 months ago, and then payment amount is how much someone paid on that, obviously. Status is interesting. So I've labeled this status. This is kind of their payment status. And it's interesting because any value 0 or less is what we'd call good customer behavior in the financial services. Those are people that either paid at least their minimum balance, is what 0 is. -1 means they paid their balance in full. -2 means they didn't use their card that month, so they didn't have a balance to pay. And then positive integers are basically how many months late they were on that particular payment. Now you'll notice that these data are, because I'm predicting for next month, these data are that status is censored. So 6 months ago, if my status 6 is 1, that means 6 months ago I was 1 month late in paying. That payment showed up 5 months ago, right? However, last month, the most I know is that I haven't seen that payment yet. So this ultimate value, status 1 is going to be a 1, status 2 is going to be a 2, etc. Do the data make sense? So and I know this is a little hard to project, is everyone here now, or pretty much everyone here? So let me first show you quickly. We've got a bunch of, you can navigate and kind of play with this here. We have a number of different data sets available here. Let me show you how you load a data set very quickly. So come up here to click on Add Data Set. And Arno talked earlier about a number of connections. We have 4 of them here, and let's go ahead and use File System. And this is the internal file system of your own instance. So it's going to be a clone of mine. Come down here to Data, and you'll notice that within Data, like I mentioned, there are a lot of tutorials online. There's a lot of help. Was there a question? Okay, let me start once more really quickly. So I'm going to add data set and going to click on File System, which is the first connector. And after clicking on that, here I'm going to click on the data folder or the data directory. And then within data, there's a whole bunch of material here. All of the data sets that we use in this training are in this folder at the bottom called Training. And here's that credit card data that I just referenced. So we could go ahead and click and say Import Selection, and it will go ahead and try to import. It actually, Driverless AI is smart enough to say, hey, I've already loaded that data set, so let's just not load it, but loading a data set into Driverless AI is very, very easy. Once that data set is loaded, and let's see, I'm going to have to go to page 2 here. Here is the credit card CSV data.
Does anyone need help getting the credit card data loaded?
Or just, no, you don't need to load it. It's preloaded, but you'll find it on the second page. And now you'll notice over here you've got click for actions under status. You can actually click anywhere along this line. And you'll see we've got details, visualize, split, predict, download, delete. So let's look at details just very quickly. Details are basically how is the data loaded and what does it look like. You know, we'll notice here that here's my status 1 data with -2, -1, 0, 1. My status 2 data, you'll notice, and this is kind of nice to explore your data a little bit beforehand. Status 2, I've got a bunch of zeros, I've got a bunch of 2s, I don't really have many 1s, etc. We'll come all the way to the right-hand side to default. So again, with the summary information on the left-hand side, I can look and say, okay, approximately 22% of the records in this data set have a default. So a nice training data set to use. It's obviously not a rare event, a little bit unbalanced, but not bad at all. So that's what details is. It's kind of nice summary information with some graphics. So let's come back. And by the way, pause me or feel free to raise your hand if you're stuck or if I'm moving too fast. I just kind of want to get to the good stuff here. Come back to credit card CSV and let's click on visualize. And as Arno had mentioned, the visualizations here are, this is wonderful, because a lot of what we do in visualization is filter out what you don't need to see. So for instance, we have this data set has about 25 variables in it. Approximately 20 of those are numeric. And so if you've ever done like a scatter plot matrix of all of the, all the scatter plots you should pay attention to, 20 is a lot of, dimensionality of 20 actually gives you, if you do the combinatorics, that's 190 different plots to look at. But there's only one, it turns out, that's important. Now, how did we decide that? You can always come down to help, and the help will describe what's happening here. It will reference the literature if it's something that is maybe less well known. And we'll also give you some kind of, we'll tell you what it's for and give you some great advice at the end, which you can choose to follow or not follow. In this case, anything that's got a squared Pearson's correlation greater than 0.95 is what shows up in this plot. And so in terms of building a predictive model, that's really the only thing we care about. Right there, and that's not to say there are lots of uses for visualizations in, in other use cases, but this is all about building a model that's really great at predicting and understanding the data underlying that. Again, just very quickly, we've got some nice outlier plots, and you can look at the plots that have anomalous points or outliers, and if you say, wow, I've got a negative value here, you can click on the point, and it will bring up the data so you can actually explore your data a little bit and try to understand that space. Once more, parallel coordinate plots, for understanding your data in a multivariate sense. Radar plot, which if you're familiar with that, same thing as a parallel coordinate plot, only polar transformation, so I can see all my variables in the same spot. You'll notice here that anything that's kind of pointed out as an outlier is in red, which is a nice feature. So this individual is responsible for a lot of the highest values that we saw in those univariate outlier plots.
So what was that radar plot
Oh, the radar plot is the exact same thing as a parallel coordinates plot. And the idea behind these plots, so these come out of engineering, a great idea, is just to visually get a sense for what your data is doing. And you'll notice most of the data, if I click on one of these lines, I usually bring up a bunch of different data points. That represents a lot of them. But every once in a while, I have I have one or two individuals that may be responsible for a lot of the extreme values in my data. Now, the purpose for this is that you can understand your data going in. You know what your model is trying to do. We're giving no recommendations on what to do with this data. That's up to you. If you've got business rules that would filter that out at the front end, et cetera, that part's up to you. But this just allows the analyst, the data scientist, the modeler to very quickly hone in on any potential data issues. Now, one of my favorite things about this really quickly before we move on is recommendations. And if you remember from maybe your intro regression class somewhere in college, you probably had a list of when data looks like this, here's the transformation we use. When data looks like this, here's the transformation we use, etc. Driverless AI will look through and give suggestions on what transformations to make on the data. But unlike a black box, right, so one can treat driverless AI as a black box. The real idea is to empower the data scientist to understand and make decisions. You can overrule this and say, no, that doesn't make sense. Or you can say, well, that's a good idea. I'm glad driverless AI found it for me. So this recommendations at the end is, just like we said, recommendations on how to use that. Now, by the way, if you come back and revisit, and I would encourage you to come back and revisit, you'll see that there are a number of other data sets that we have visualizations for. Some of these fairly famous, like the Titanic, who survived the Titanic sinking, etc. And there are some plots in the Titanic one that aren't available in Credit Card because they weren't applicable. Right, in the Titanic data set, there's some missing data, so there's a missing data heat map, etc. So, again, feel free to come back and revisit. Question?
Yeah, question on the visualization. If we have to do some visualization on some network kind of thing, for example, text summarization, text rank, we have to build some kind of a distributed graph. Does it scale up to like large text? Of course, I understand what you're
My question is basically on visualization of large graphs. How does it scale up? So if I'm doing text summarization and I want to actually build in Python comparison, it would be network X, which doesn't scale up. Can I use this visualization for visualizing large distributed graphs?
So in general, and if I say anything wrong, I'll have Arno correct me because he understands that. So the purpose of the visualizations here is not a general purpose package. This is for predictive models that you're building. So these visualizations in this context scale very well, right, with the data. I'm not sure that we have the specific plot you're talking about as one of the options here, because these are just automatically built for me. Well, they're not quite automatically built, right? They're only automatically built if I come to Credit Card CSV and say visualize. And when I click visualize, it will go ahead and create those. So Arno.
Yes, so these plots are for numbers and strings only. So there's text really is not handled that well. It would be treated as categorical, and then it will just do some kind of a mapping of whether it's like correlated or not to another categorical maybe, or to another numeric column. It won't do NLP recipes. For that, you would have to wait for Q. The other product you saw, Shri demo earlier, that will have custom visualization recipes where you can do anything. Now, this is scalable, so 100 million rows visualizes in like 30 seconds or something, right? So because we have an aggregator inside that's smart, it's basically clustering with epsilon bubbles. So you pass an epsilon bubble around, and everybody who's close enough gets sucked into that epsilon bubble, and in the end you have like a counter going up. So every bubble is like a count of how many people are in that bubble, And that means the actual data set visualized is small, but you still have all outliers. Because if an outlier, you just count have one, right? And if you are together with us, then you have count of 100. So it's a smart way to visualize big data sets, but not for text.
Is there on the pipeline, like distributed graphs, visualization system on the pipeline?
We'll have to see what we can do in Driverless, because this is written in Java somewhere else. It's not part of the customizable recipe, so it's a little bit harder to customize. That's what Q is for. Sure.
I had a quick question around pruning the data. So let's say we have a certain set of outliers that are visualized here. Is there a way to just remove those outliers and visualize the heat maps? If we have a highly correlatable variables, is there a customizability where I can only look at a heat map of 10 variables that I know are of value, so that I'm not looking at a 10,000 by 10,000 or even like a 50 by 50 heat chart is harder to read.
So,
Yes. Sorry, so the new version has a custom data correction facility inside the Driverless API, right? What I showed you earlier, that live code preview, you can take your data set and say, drop everything but those 10 columns. Then you get a new data set, and then you say visualize. Not really. There is a UUID for every data set, but we don't have full lineage yet.
Right, and so, thank you. So that's not available on this version that we're doing, and what anyway, so it will be available shortly. If you're working on 1.8.0 or earlier, in essence, this was just to let you hone in, and I would say if you're up here using the Python client or the R client, that you would do the filtering there and reintroduce the data set in general as a process.
There is actually a Python client version for Autobase where you can make custom graphs using this smart aggregation facility. So you can say I have 100 million rows, I want to do a scatter plot of X versus Y. From Python you can say that, and back in your Jupyter notebook you'll get a nice plot. So this is like Leland Wilkinson's visualization program for you for custom plots. So you're not just stuck with these plots. That came out in 1.7, so this version has it also. And it's in the documentation on the website.
Okay, so let me show you the next. So we've talked, and again, I apologize, we're kind of flying through this to give you sort of a quick overview. On actions here, we've done details, we've done visualize. Let's go ahead and let me just show you the data splitter. And the notion here is if I'm going to create a training data set and a test data set, and you always want to do that, down at the bottom, you've got a slider, or if you just want to enter a number like 0.8, that's going to, 80% is going to be on the left, 20% on the right. Come here and select target column, and we'll go down to the bottom and click on default under target column. And what that does is that target column is Boolean, and so because it's Boolean, Driverless AI knows that it needs to do a stratified sample rather than a simple random sample. So this is just indicating to Driverless AI how to do your split. We'll go ahead and save this data, and very quickly, just sort of a nice convenience function. There's you may have noticed there's a seed there, so if you want to make that reproducible rather than saving those test and train data sets off, you can just redo that using the same seed. So now that that's done, come over here to page 2. If you've done it like I have, come up to card train, because the next thing, if you come to credit card CSV, the next thing we're going to do is predict. But as we predict, we've split the data into card train and card test. So just to make sure we're all doing the same data, come down here and click on predict. Tell it you don't want the tour at this point. And you're going to be presented with, and let me zoom in on this a little bit if it can zoom in on the screen. You're going to be presented with this, right? With a blinking target column, a name, you can call it my card experiment or some other name you want to give it. If you don't give it a name, we'll randomly create one for you. Come over here. So I would suggest before clicking the target column, come over here to test data set. Oops, and I need to zoom back out so you can see it. And come down to card test. And the reason so number one, you always want to test data set attached to this. The reason will become obvious in just a couple of minutes. There's a test data set. Now select your target column. And so the target column, we're going to go down to the bottom and select default. And once this happens, I have sort of a whole bunch of spinning things, and the display gets very busy, and there's a lot of stuff going on. And so often we forget about what's happening above. So let me tell you, there are kind of multiple levels of using driverless AI. If you want to use driverless AI as a complete black box, then the way you do it is just come down here and click Launch Experiment. And believe me, the suggested settings, all this other stuff that driverless AI has given us, it's still going to build. It's got some very nice guardrails. It's still going to build a very, very good model for you. But that's using it at its most black box-ish, and for most modelers and most data scientists, statisticians, econometricians, et cetera, we'd like to understand it a little bit better than that. Okay, so we'll leave it at that. I call that like my summer intern mode, or I have a 10-year-old son who is a Python coder now a little bit, and he gets to do driverless AI. That's the button he pushes, right? So that will build a good model for you. The next level has these 3 knobs. Now, I should mention really quickly the scorer here that's blinking at you. It has selected AUC, which is the default for a non-rare event classification model. You can feel free to change this, select a different one, or later today you will hear about how to create your own via a recipe. So if you've got your own custom scorer, if for instance you have a specific cost for false positive and false negative within your business that you want to have the models scored on, then you can use that. Now, it's going to get a little bit complicated down here. So before I get to this 546, I just want to reference you. Come to Resources and go to the bottom and click on Help. I'm going to show you where all of the details are in here, and then I'll give you a sense as to what's happening. So in Help, if you'll come down to using driverless AI on the left, and I'm sorry, let me make the font here a little bit bigger. Click on Experiments. Click on Experiment Settings. And now, as we come down, here's the section on those different knobs. And for each knob, so let me come back here really quickly. Each one of these knobs goes from 1 to 10. And so because I've got this knob labeled accuracy and a knob labeled time and a knob labeled interpretability, you can scale these kind of up and down. That gives you 1,000 kind of unique recipe combinations to build a model off of. And again, a very nice, you can build some really terrific models using this. So really quickly, on the left-hand side here, we give you sort of a summary of what's happening with each of these knobs. So very quickly, accuracy. I need to point something out about accuracy. It's hard to find the right name for this, because in reality, even if accuracy is at its lowest level, at a 1, we're still going to build the best model based on the score. So we're still, optimizing that. So in essence, we're building the most accurate model we can. This really is, I don't know, there's a sense of amount of effort, right, how deep we're going to dig in with this accuracy, because accuracy really impacts a couple of things. It impacts how we're going to do feature evolution, and it impacts what that final model is going to be. Will it be If accuracy is low, it's going to end up being like an individual model, in this case a light GBM or an XG boost. If accuracy is high, it's going to end up being some kind of ensemble. So it figures in both feature evolution and in how that final model is built. The time dimension over here basically is saying how long am I going to let my features evolve, right? So if you think of an evolutionary algorithm where features that are doing well survive and features that don't die off, this in essence is telling us how long that will work. Once more, all of the details, because this gets fairly, well, time is pretty straightforward. Accuracy gets fairly complex. There's a lot of things going on. Let me make one suggestion though in general, and this isn't 100% true, but we can play with it and I'll show you some examples in a minute. If driverless AI suggests like a 6.4, it's fine to move these around and experiment and try to find an ultimate place. I would just personally avoid going to that, like a 10.10. Generally, it's going to end up overfitting. You won't get a good model. So let's come back to about what it was. I think I had a 5.4 or 6.4. So last thing, right, interpretability. This knob, in essence, and again, under the hood it's very complex, so you can go back to the help and look at what it's doing. But the general idea is that if interpretability is 1, we're going to throw the kitchen sink at it. We're going to try all the model types. We're going to do every transformation. I don't care whether I can interpret it or not. I just want something that will work, black box or not. As I increase my interpretability, I start kind of constraining the types of things we're going to allow to happen to try to make it more interpretable. And so personal from my experience in like insurance and financial services, if I were in a space where I had a regulated model, I'd tell you that starting at about a 7, so 6 and 7, I probably wouldn't start below that. And the reason is, one little thing I'd like to point out here is that at 7, oops, and this isn't, there we go, I'm zooming in a little. At 7, I have monotonicity constraints that I can add. So in essence, I'm not building a black box model. This is more like a white box model, right? I'm enforcing monotonicity on my gradient boosting machines, etc. So that being said, you know, there are lots of different combinations we can do here. I've been talking for a bit. Maybe move your buttons around to somewhere comfortable and click Launch Experiment. And we're going to let this spin for a minute while the experiment is launching. And let me show you all these experiments. So we have this datasets tab or label up here. We've got the AutoViz that we talked about. All of the experiments live under this experiment heading, and this gets fairly complex, right? Because we've got lots of different experiments from different data sets, etc. So while that's starting to spin, I just want to show you, come over here to projects, and I've created a project for all of these card default models that we've built. And you'll notice that I've kind of pre-built a bunch of them. Let's go ahead very quickly and link the experiment that we're working right now. So I'm going to click Link Experiment. Here's my card experiment. So that one now is going to be one of the members of this leaderboard. It's still working. It's still building. Let me actually come back to that one really quickly. And let's see what's happening as we start building this. So first off, really quickly, each one of these dots is an individual model that's being built. So already we are building a number of different models, 10 out of 14 parameter and feature tuning models, etc. Here are the variable importance. Here you can see I've got my ROC curve with all of my metrics and confusion matrix, etc. So I've got a lot of stuff going on right here as this is building and evolving, and we're going to allow it to evolve as best it can, again, based on that recipe that we chose. Was there a question? All right, let's get a microphone. Do we have a microphone?
Can you set up a recall threshold before you start the experimentation?
Can I set up a recall threshold
Yes.
for,
That would be a custom scorer then, right?
In my case, say I want
Yes.
a recall, class 1, for example.
Yes.
yeah, so we'll
You can
talk
make a
about that
custom-
later.
95%,
Yes,
no less
you
than
can make a
that.
custom scorer and you can hard code the threshold to 95 and
you
then
can-
you get your metric based on that.
Okay.
But our AOC curve will still show all thresholds,
Yeah.
right?
Yeah, great. Was there another question? I saw another hand.
Let me understand. You're going through a feature engineering, then a modeling process, and then cycle back through the whole thing?
Yes.
Simultaneously?
Every single yellow dot is a full pipeline that's fitted. So not just features, but feature plus model. The only thing how you can tell,
Okay, is that
yes,
simultaneously you're developing features and models?
yes, we change everything. It's not just features, but we change features and parameters for feature engineering and modeling. So the whole pipeline is tuned over and over again. And there is a race going on, like a genetic algorithm, but also particle swarm in Monte Carlo. So it's like a smart search, let's say. And there is bad individuals that are losers. They get eliminated over time, and the good ones kind of survive and then mutate and so on. And then they listen to others who have won in the past, and they'll say, oh, let me mimic your behavior. And then they all exchange information about the feature engineering. For example, these three groups are good to group by and to compute mean, median, min, max, and so on. So they share that information. It's not that every model is on its own in random search land. Yes, so cross-validation is triggered once you go to like accuracy 7, 8, and 9, and so on. You can look in the preview on the left side. So the preview is always accurate. Whatever the preview says, that's what's going to happen. Our documentation might not always say the exact right numbers. Let's say when you turn the knobs, it might do different things for different sizes of data. So if you have 100 million rows, it will do something else for accuracy 6 compared to 20,000 rows. Because we know if you want accuracy 6 on 100 million rows, maybe all you need is like, 1/3 of a data set as a split for validation, or 1/4 or something. But for small data, you need to do more folds, more repeats, and so on to get a good accuracy. So we do whatever it takes for a given data set. And the preview on the left side is always what will actually happen.
So one of the wonderful things as a user, and all of our great makers who built driverless AI, but as a user, it's just amazing the amount of work that gets done here very quickly. I have control based on my settings of whether it's going to do cross-validation, whether it's going to do 1/3 validation split, things like that. Before we go on to the results here, so come with me to experiments really quickly, and you can click on, if you ran one, actually, to make sure we're all at the same place, come to projects and card default. And this model that was pre-built up here, this card default, was basically just the default model. If you'll come to the right, you'll see 3 dots. Click on those 3 dots and say new model with same parameters. This is how I like kind of building my second model after I've built my first one, because I've already filled everything in. And let's just open up expert settings for a second. So for those that are here, expert settings gives me sort of my third level, right? So the first level was complete black box, just hit go. The next level is, okay, I've got 3 dials I can mess around with, right? The third level here is I have complete control in terms of, here are the models. As Arno mentioned earlier, I can turn some on, I can turn others off. I have feature engineering controls. How much feature engineering do I want to do? If I'm working a time series or NLP problem, I have, again, great control over what's happening there. And then recipes. I can come here and right now include or exclude certain transformers. So maybe you're working in a regulated space and you've got a regulator that says, no, I don't want you doing this type of target encoding. You can turn those off so they're not available to driverless AI at all, and go ahead and build your model customizable. But one of the things, and that's the next level. The ultimate level, which again was referenced, and we're going to do a training a little bit later this afternoon, is building your own recipes. So you can create your own specific model, or wrap a model you found out there, like a cat boost or something, and include that. You can go ahead and, let me click done here, you can go ahead and do it with a scorer. You can include your own transformer, like I believe the text sentiment was like from TextBlob, right? You find a great Python package and you want to include something from that package, but use the whole infrastructure of driverless AI underneath to build, to kind of build this best evolutionary pipeline. That's how you would go ahead and use it. So there's a lot more that you can do in terms of details and customizing your analysis. And real quick, the reason for giving that preview is, let me click back here. Let me go to here we are at projects. I just want to explain very quickly what's happening in this project, because there's some kind of nice comparisons we can make. Go ahead and click select scoring data set on your own, and we'll click card test, and then select scorer, and in this case we used AUC. And once this is done, you'll notice that now it's populated. So I've got my validation score, I've got my test score, the time it took to do the test. This last one we built, we haven't validated yet, we haven't completed, but let me explain really quickly. Here's the card default. This is my black box approach, right? Driverless AI suggested something and I built this model, and let's go ahead and rank order these in terms of, turns out in this case, right, the driverless AI actually built the best model available without me doing any tweaking. Now, maybe there are other reasons for tweaking, because best predictive power isn't always the thing you want in a model. It's got to be a certain level of explainable. It may have to include or exclude certain techniques, etc. So the next thing I did was I said, okay, I built something called card monotonic, where I moved that 6 in interpretability up to 7. It took about 5 minutes to build the card default. It took twice as long to build the card monotonic, but that's not that much longer. Comparable validation, again, comparable test scores. I don't know what the variability is around these, but not quite as good. And then I said, okay, from card monotonic, let me really crank up accuracy to 8 and time to 6. And you'll notice cranking that up, it took 1 hour and 11 minutes, right? So it took, I don't know, that's 70, it took 7 times as long as this first one. And it really didn't, it improved a little bit, but not very much for all that additional time, which I would argue claims that this 647 settings were sufficient to sort of extract all the information out that was interesting. So let's go ahead and compare these, by the way. Let's go ahead and compare these 3 models. Yes?
So like we could adjust different knobs, how many various attempts we should make to keep trying all of these? Otherwise, we could probably just keep trying, not sure how far we should be going.
So that's a hard question to answer, because you have to be, I don't know what your use cases are. As an end user, in this case with this data set, after I've done 5 or 6 models, I have an idea of what the best I can get out of it is. Now maybe I go and I take that to my business partners, to my model review folks, to my regulatory people, and they say, oh, show me what you did. Oh, guess what? You can't use this. right? Or I don't want an ensemble at the end. Make it the same thing, but strip the ensemble. All of those, in terms of making this a product that's very easy for you to go back and remodel and redo things, it's wonderful in that aspect. I think you'll get all I can say is you'll get a sense as you work on a specific problem how many to do. I don't have a good recipe for that, except based on my experience using it. It doesn't take that long. Now, if it's a big complex problem, if it's a time series problem or an NLP problem that has kind of other things going on with it, I'm not sure I know how to answer that, except I wouldn't use this and just build one model and trust it and go on from there. But after you build a few, you'll start to see what's adding value or subtracting value. So again, Arno, did you have?
Yes, so I would say, we'll add that in the next version, is when you're in the projects page, right, you want to see that leaderboard. But right now we are telling you to make those 7 models and then compare them. We want to add a button that does those for you, the baseline models. So you'll get a GLM, a single decision tree, a XGBoost, this kind of random forest, all these baseline models, maybe a TensorFlow model, maybe an H2O model. And then once you have that leaderboard out of the box, you at least know where you stand. And then we can do the defaults, and if that's much better, then you should say, oh wow, something we missed here. And if it's all the same, then you can say, okay, we squeezed enough. But you will never ever know what's possible with any given data set unless you kind of crowdsource it for a few months, right, on the whole planet like Kaggle. And only then you'll see that there was a leak in the data and you have to start over again or something like that. So it's always a tricky question. It's really it's an unsolved problem to know how much juice is in the data. But at least this will help you make a leaderboard fast. And you can automate, of course, the leaderboard creation, but it's our job to do that for you. So.
Just to add on to that question, right? So let's say I'm playing around with 10 different experiments. I know certain experiments doing well, certain models are doing well. So when I try to reconfigure and run hyperparameter tuning for that same 2 or 3 set of models, does it happen to the same page, or is there
Yes.
a way?
So there's a couple points I need to make. So when you rerun another experiment on the same data sets, the model will get smarter because it already knows what features work. There's a brain built into the system on your hardware. We don't have that brain. It's your brain. It's your IP. The system will get smarter over time. So if you run 10 experiments, they all get smarter. Now, at some point, it saturates. Another thing you can do, every single experiment, you can say retrain final pipeline. On the right side there, we should probably show that at some point. That's a good one. You can retrain any experiment, whether it's finished or not, and say, make me one more. And then you disable LightGBM, or you enable TensorFlow, or you drop everything but target encoding, and you can redo the final pipeline just with those changes. You can even change the data set or the columns that you're dropping. You can change anything and say retrain final pipeline. And whatever works still from the past will be used, and anything else will be filled in. So if you add 10 more columns and you say retrain, it will do the same feature engineering on the other columns, but for those 10 new columns, it will start fresh, and so on. So you can also say restart from the last checkpoint and continue some more iterations to evolve. By default, if you say retrain final pipeline, it will just make the final pipeline. It will not evolve anymore, right? But you can always evolve a little bit longer. But it never starts from scratch unless you turn off that feature brain. But basically the system is there to get smarter. And if you add or remove transformers or models or add custom recipes and the whole thing flatlines after like a week of trying everything under the sun, you can say, well, I did my best at least. You can never say more than that anyway. But we have built in these checkpoints to facilitate power outages or server restarts and so on. You just restart and it will finish. It will not actually have to start from scratch.
Sorry, small variation to that. So you said there's this context brain that it maintains a lineage. So is that at a user level or at an installation level or at a company level?
Installation level. Every driverless has a folder with up to 20 gigabytes of pickle files from previous experiments, and they get rotated. So it's actually not something that's 100% reproducible, because that state can change, right? So if you really want a reproducible experiment, you click the reproducible button between time and interpretability, and then it will turn off that feature brain and will start from scratch, so that every time you run the same experiment, you get the same output.
One quick question there. You mentioned the final
You mentioned the final pipeline that you could rerun it. What's part of that final pipeline? Is it just like, does it take all the features as all that it built and just run the model?
Yes. So
or
the
train
final
model?
pipeline is all that you need to put it in production, and also to have the scores on the test set, let's say, and on the training data. So it basically fits the best genetic algorithm winner or winners on the full data set, and makes the model that you would put in production. So it's the output at the end of, like, this last final screenshot, the number you see, that's on the final pipeline. And if you say, make me another final pipeline, it will redo that last stage. And ideally, it would then change something so that it doesn't do the same exact work again, right? You would want to add some features or drop some columns and see what happens. But often, a good idea is to drop the best feature and redo it and see how you can squeeze the other features, right? So that you can see whether you can make a more diverse model.
So if I may, we've only got about 5 more minutes. Let me show you really quickly just where to find 2 more things, and then from there we can, feel free to come ask me questions. That's what this whole thing's about. Feel free to. We lead lots of trainings online. We lead. There's lots of tutorials. We've got that next training set. So this is a chance to kind of get in and look at it quickly. Click on Interpret this model. And this is all the stuff you're seeing today about MLI that Patrick Hall and his team are working on is available here. If you'll come to Dashboard, this gives a really nice view of, this is a K-Lime model, surrogate model to explain what your black box model is doing. Here's a decision tree over the top of it. Feature importance and partial dependence plots to, again, this is so that you can understand your model. But the one thing I wanted to point out really quickly here is, so we've got, under the driverless AI model, we have feature importance, we have Shapley, if you're familiar with using Shapley values to explain things. These are all in terms of the transformed data set, in terms of the transformed features rather than the original features. But I wanted to just show you where disparate impact analysis is, because we've highlighted that a few times. That's really important in a lot of regulated industries. Disparate impact here, and let's see, let me look at what I can barely read. Oh, here we go. So I want to see, in this data set, I've got education, and so I want to see if across the different levels of education there's adverse impact. Here's N, here's adverse impact, accuracy, true positive rate, etc. Right? We have a whole tool built here for you to be able to very quickly see if your model, again, maybe due to the data or other things or things you've got in the model, but this will give you a quick view of disparate impact. Now, by the way, let me come back to Aquarium really quickly and show you a couple of things that, we've got a number of tutorials. You're also welcome, as you browse these labs, to this open source MLI workshop. Is a workshop with materials that are available that Patrick and his team have put together. So if you kind of want to know what's going on under the hood, this is all done in Python, so you can see the Python code for doing all of these things, and for some of us that makes it easier to understand. Again, feel free to come and use this resource or our tutorials as well. But that was the first thing I want to show you. So I apologize for doing a flyby of MLI. Usually we spend quite a bit more time on explaining this and explaining what Shapley values are and how they work. And again, we have sessions today discussing Shapley and the fact that with a tree-based model you can compute Shapley very efficiently is kind of magic. Last thing I want to show you, because this is the most important thing, if you're a data scientist who builds models but nothing ever goes in production, whatever you call yourself, you're in R&D, right? Without things going into production where they impact an end user, you're not really having an impact on the business. And for a data scientist, that's not a very fun place to be. So if you'll come here really quickly, you'll see something called Build Mojo Scoring Pipeline. In my options, I can turn that on so it does it automatically. I'm going to go ahead and build my Mojo Scoring Pipeline. And now that I've built it, I'm going to deploy it. So click deploy. This is beautiful. This is a one-click deployment. Let's deploy it to a REST server. So this is a local internal REST server on the same EC2 instance. Now, part of the reason for doing this is really nice and convenient. It's also, you know, if you have friends that are engineers that you work with and you show them this, they immediately understand how this works and go, oh, I can do that, right? Point them to the documentation. This is going to take about, I don't know, another 30 seconds to deploy this. But the thing I want to show you is we've gone from building a model to literally being able to deploy and score. And deploy means not using any of the driverless AI software anymore. I've got this artifact, this piece of code that now I can throw my data against, and it will return predictions for me. So in just a second, this will be finished. And I guess while I'm waiting for this, we got a couple minutes for a couple more questions.
One thing to stress is that this pipeline that is in production is the full deal. Full ensemble, full feature engineering, no shortcuts. This is not a surrogate model. It's not a rule fit, anything. It's the full XGBoost, LightGBM, TensorFlow ensemble, whatever it is productionized. C++ or Java with R and Python bindings or command line. And the custom recipes, they are coming as a Python package first, because we might not have a Mojo or Java runtime for your ARIMA model, right? If you have your custom logic. So if you have a pip install somewhere in your custom recipe, we can make a wheel, a Python wheel that is shipped fully self-contained, but it still is going to be Python because we need to call your Python code. But if you work with us, then we can make a Java version of this, like we did for all of our transformers, so that it's purely Java or purely C++ runtime without any Python dependencies. So anything is possible. We've done most of what's possible in the world already today. PyTorch and so on are standalone C++, for example, without the need for Python.
So it looks like our time is up. Again, this was a quick flyby, and I would love to do a deep dive. We have a community site that we'll be launching in the next few weeks, and on that site we will have a list of virtual trainings that you can attend. If you want to learn more, I would suggest, so two things that I should put up here side by side is our tutorial site and our Dive into H2O event on November 4th, where we're going to spend, we spent a little more than an hour just doing a hands-on here. We're going to be from 9 to 5 doing a full day hands-on where we can dive deep into all of this. It's well worth the trip and the price of attending to do that. So anyway, thank you for your attendance. I think we have other people coming in for the next session, but I appreciate it. Feel free to come back and use Aquarium anytime you would like.